Wide Field Camera 3 is one of those instruments that's going to make Hubble 10 times better in discovery space. It's the highest science priority on the mission, and we're very excited to be able to put this new camera in.
We do have to take out an existing instrument that is still operational, and that is the fabulous WIFPIC 2. I mean, that has been the workhorse imager for HST for much of the HST lifetime, from its installation in the 1993 first servicing mission. It was the first camera that gave the kind of images that HST was intended to provide. So many of the iconic images like the Eagle Nebula, Pillars of Creation, and so on, those are WIFPIC 2 images.
Wide Field 3 is probably 2 generations improved over WIFPIC 2. Wide Field is what they call a facility class instrument. What they did was assemble a team of scientists, and they got together and said, let's put together the best possible instrument that can give us the widest possible scientific use.
The original design of Wide Field, the day one design of Wide Field, was very similar to WIFPIC 2, in the sense that we had a single camera. However, it was decided to add a second camera inside the Wide Field Camera 3. We want not just great UV visible performance, we want great infrared performance. And that caused us to take the initial design, which is essentially pretty full, 5 pounds of sugar in a 5-pound bag. It all fit quite neatly. And now we had to add a second 5 pounds of sugar into this bag.
There is so much stuff inside Wide Field that all of our electronics boxes have to hang on the outside. And it looks a little bit like Fibber McGee's closet, with harnessing and all of these wires and cables, and everything's connected all funky. And it's just because they're trying to do so much with this facility class instrument. It's the last imaging instrument that's going to be put on the telescope. We want it to provide spectacular imagery.
The most novel technology, however, was the infrared arrays. The infrared is particularly good at looking at the very distant universe. And when you look at things at a great distance in astronomy, you're also looking far back in the past. So closer to the beginning of the universe, closer to the Big Bang, earlier in the lifetimes of galaxies and so on.
Because Wide Field Camera 3 has this wide panchromatic color coverage, we can progress from ultraviolet to visible, and then progress onward beyond that to the red and the near infrared. And as we do that, we're progressing from hot young stars to middle-aged stars to older stars within the same galaxy. And all those different populations of stars exist within the same galaxy. It's the family album, the family photo album for that galaxy.
The other thing is to probe this very mysterious phenomenon that's called dark energy, which is the catchphrase for a force that is not understood in terms of the physics, a force that is accelerating the expansion of the universe.
What's been so amazing about each of these cameras over the history of the Hubble program is what it finds is something we never knew. We point it, we learn a little bit, and somebody goes, huh, I wonder, and off they go. And then the world has changed forever based on something that we could not have imagined while we were down here on the ground working on it.